Hello, everyone. Welcome to our webinar today. My name is Konstantin, and I'm your host today. And today we have with us Akmal Chowdhury, a Senior Technology Evangelist from SingleStore, as well as Jorge Torres, CEO of MindsDB, together with Patricio Cerda Mardini, a machine learning engineer from MindsDB. And before we jump into our presentations, let me briefly introduce you this event platform. On the right-hand side, you have a chat window, and you can chat, you can ask questions along the event, and we will go through them at the end. But if you want to ask a specific question related to the content you hear, it's better to use, it's more recommended to use questions tab. You can enable it in the bottom right corner and leave your questions there. It will help us to make sure that we don't miss anything. Additionally, you will be able to download this presentation at any time during the event. Just click the download button on the right hand side of your presentation window. And the recordings of this webinar will be made available to you right after the event. So the agenda for today is displayed right now, and I will not steal time from our presenters and let them start. So first, welcome on stage Akmal Chowdhury, Senior Technology Evangelist from SingleStore. So Akmal, the floor is yours.
Thank you very much, Costa, and greetings to all of you. Good morning, good afternoon, good evening. So I'm based in London, and it's just gone 6 p.m. my time, and it's dark outside, so it's still winter time. And so thank you very much for joining, and thank you very much for MindsDB for inviting SingleStore to participate in this event as well. And so a little bit of background on myself. So essentially, I've worked in database technology for a very long time, and I spent quite a lot of time working in a variety of different roles. So I've worn many hats over the years in technical marketing as a developer, even being an academic and researcher as well. But the focus has always been database technology. And over the last couple of years, I've become quite interested in machine learning as well, because I think this is really something that we can utilize today quite effectively. All of us can become machine learning engineers or data scientists to some degree because the tools are available to help us to do this and to achieve this now. Whereas in the past, it was much more the domain of a specialist, principally, I think, because we didn't have the resources in those days. But SingleStore itself, very much focused around this concept of data intensity. Okay, so the thing is there that go back in time a couple of years, and people often refer to something called the 3 V's. You know, you had this volume, variety, velocity. And so I think that this data intensive can really, we can talk very much around the volume and the velocity. Of course, SingleStore can handle the variety as well. Okay, we've got a slide coming up, and I'll discuss that in a few moments. But the challenge is that we have to deal with vast quantities of data today. Most organizations don't have the time or the opportunity to get insights into that data. So they're storing up all this data, but don't actually get much value out of it. And that's a shame. Okay, I mean, there's a lot of sort of golden nuggets, if you like, many pieces of information there that could be very useful to them. And this is really, I think, where something like machine learning and data science can help us. Okay, so being data intensive, as you can see from this, it looks like sort of spaghetti, if you like, but there is a lot of complexity there, lots of moving parts. That is quite a challenge. In today's world, being able to utilize a variety of different tools and technologies together, although there are standards out there, it can still be, quite challenging to be able to glue all of these together, get them working properly, and to be able to get the insights as well. And so if we look at this diagram, we can see that we've got things like OLTP requirements, we have data warehousing requirements, analytics that we must run, and this concept of data lakes, which has come to the fore over the last couple of years as well. On top of this, many other things that we need to do in terms of model development, for example, down in the bottom right-hand corner, you see the data science aspect of this. And so that is something that's new and added on, and we have to really think about that as well. And so in a sense, if we look at this, this is a much more simplified picture of the previous diagram. SingleStore can actually consolidate many of those requirements. So this concept of universal storage. So it can do the transactional based requirements, the OLTP, and it can do OLAP as well. And it can give you streaming analytics too, okay? And if you're familiar with perhaps a lot of these open source technologies around today, such as Postgres and especially MySQL, well, it's great to be able to move across from these technologies to something that will give you much more scale. If you are familiar with MySQL, for example, in particular, then SingleStore is MySQL wire compatible. So lots of tools, technologies that you're already familiar with, you can use directly straight away. Next slide, if we take a look at this. So here you can see that we've got some additional capability here being added through MindsDB. So SingleStore is great, but can't do everything, okay? And this is where MindsDB really comes into its own. It's the ability to integrate this, to be able to utilize this, take advantage of the storage and capabilities and the distribution that SingleStore provides, cloud-based environment as well. That's great too. And that gives you many, many benefits. So in a sense, what we're trying to do is to make it easy for developers to be able to use the tools and technologies they're familiar with, make it easier for them to learn something as well, rather than having to learn half a dozen different products, and additionally have that good integration as well, and take advantage of these modern data science, machine learning capabilities, which I think are going to be very, very important in the near and coming future. So here is the kind of the big picture, if you like, the 30,000-foot view of SingleStore, and in a sense, this kind of captures very succinctly everything that's good about the product. So in the center, you can see that both in memory, okay, that's for the OLTP side, as well the disk-based column store, great for analytics, okay, sum, min, max, average count, all of those can be done, and it's universal in terms of providing both of those capabilities. And on the left-hand side, we can see these modern kind of streaming technologies such as Kafka and Spark, for example, for ETL. On the right-hand side, it's a multimodal database system. And this is where the variety comes in, okay, from those 3 Vs that we discussed just a couple of moments ago. So the ability to handle other data types rather than just pure relational. So things like geospatial, for example, JSON, key value, time series, and full text search, for example. And again, your choice of where you want to run this. So it can be on-prem. You could do it as a managed service in the cloud, which I happen to like a lot and use very frequently. It could be self-hosted. Okay, so that could be important, for example, if you have some concerns or there's some particular security requirements that you have. And containers as well. Okay, that's a very modern approach today as well. Along the top, we can see then the kind of things that we want to do, you know, dashboards, ad hoc queries, machine learning, real-time decision, IoT, dynamic experiences, lots and lots of use cases we have, many, many customers doing a whole range of things. But here, specifically, we focus on machine learning today, and MindsDB and their integration with SingleStore. And therefore, I'll hand over now to Jorge and move on from there. Thank you very much.
Thank you, Akmal. Thank you, everybody, for being here, and thank you for that amazing introduction. I think that one of the most amazing things about working with SingleStore is how they cracked the most difficult part for machine learning. I think that, as Akmal was mentioning before, the barrier of entry to machine learning was very high at some point. You needed to really understand deep concepts of mathematics and statistics, and the barrier of that is lower and lower. And right now, it feels like the most important thing continues to be data, and will always continue to be data. There is no machine learning without data, and SingleStore makes this possible. Let's walk a little bit into MindsDB and the story of MindsDB, and we'll just cite these 2 amazing stories of how SingleStore can empower so many people to do machine learning, and MindsDB can be that agent that enables the machine learning world to the SingleStore community. So we started in December 2017. and the first lines of code for MindsDB were produced in 2018 January. And up to now, we've raised $7.8 million in seed. We went through YC. We're also Berkeley, UC Berkeley Skydeck company. And the reason why we were named one of the America's most promising AI companies, it's because we see that the world of machine learning and applied machine learning in particular can still be disrupted so that many more people can apply machine learning to their problems. The world that we saw had a few issues. Traditional data analysts and traditional developers can solve current predictive challenges in a very smooth way. And the reason for this is that not only machine learning models are difficult to build, which is a problem that has been solved to a great extent by many AutoML frameworks today, but also the ability to bring those models into production so that essentially all of the state-of-the-art of machine learning can be applied directly to data that people have in production is still a challenge. And the way that people overcome this challenge today involves transforming a lot of data, taking data out of the database, and then through like many flips and transformations, fit that into a model that is kind of hosted in a web service, and then take that data back into where it's needed, again, back into the database so the actual application developers can build something or the data analysts can analyze it. And this back and forth could be simplified. So we start to understand that there are three main blocks on the machine learning lifecycle, or the ML ops lifecycle, if you may. There's the data preparation, and that's the data acquisition, data cleaning, feature engineering. There is a modeling, which is a model selection, hyperparameter optimization. There is the actual ensemble of the model, and then validating that your model works. And once that happens, you need to deploy it. It felt that if you start in the traditional way, essentially, if you start with data as an ideal data set, and you start massaging your data through pandas and all these different techniques that actual data scientists they use, you still a little bit step away from really the origin of this data. And many people forget that a lot of the things that you're doing in pandas and you're actually doing in a Python script, you could be doing directly in the database. Databases have been around for quite a while, and as you can see, for instance, SingleStore, it's leveraged on, or has leveraged on, the experience of 30 years of database building, so that anything that you need to do with your data, you can do there. And it doesn't make sense for someone to try to reinvent the wheel when you have a tool as powerful as SingleStore, where you can do all of the data acquisition, so you can pipe as much data as you want into SingleStore. You can do all the cleaning prior to getting there with like tools for like loading the data there, but also the language itself and all the capacity that the SQL language for SingleStore has for you allows you to transform the data in probably any shape you want. And then after you do this and you have your data into SingleStore, in a query, what you get in result is a table, and each column is a feature. So this concept of feature engineering is on the hands of anyone that today is a SingleStore user. So assuming that you are already a SingleStore user, you've accomplished, even though here it looks like 30% of the task, this is the most difficult task. So any SingleStore user today is already almost all the way there to being kind of like a very proficient machine learning engineer or data scientist, purely because they can leverage on all the capacity of SingleStore to actually manipulate data. And therefore, you're almost there. And what we thought is, well, why don't we abstract all of this complexity and allow people to do all of the machine learning lifecycle in SQL? So understanding that data preparation and feature engineering is done in SQL, what we can do is create a concept that allows us to abstract machine learning in the same way that you're used to when you're doing the database. So the best way to convey this story is if I walk you through a simple example. In order to do machine learning as SQL, or like using SQL-like syntaxes and in a SQL-like environment, let's start with assuming that you have a simple table. This table has income and debt. And databases are designed to give you answers when whatever you're querying has an exact match into the database. That's what they're great for. And then you can transform, of course, data so that the queries that you're running to can hit actual data that you have in the database. However, they're not designed to give you an approximation to questions that may be very close to data that you already have, but they're just not designed to give you approximations. Machine learning, on the other hand, is. Anyone that has built a model understands that you can build a surface that can fit all your data. And what we thought is, well, if you're already coming from the world of databases, let's create a syntax that is very similar to that of creating a view, so that you can create that model and train it to fit that data. And the syntax is very simple. Is you create a predictor, you give the predictor a name, and then from what information you want to learn. This can be a query, this can be a table, a view, and then what columns you want to learn. And then once you do this, you can query that line in this case as if it was a table. So now you can get answers for information that you don't have to necessarily match in the database, but you get an approximation for. So you can query the model just as you would query a view. So select income debt, the predicted debt from the debt model, and then when income is, I don't know, 90,120, and then you get an answer for this. So this intuition enables you to think of machine learning model as a building block that is similar to all the building blocks that you already have in the database. Yet it is very powerful because now machine learning becomes a first-class citizen to your data layer. And it's very interesting because now you can use all the tools and all the understanding that you have of databases to also get predictive capabilities. So in this journey, we also started to understand that many of the problems that people have in databases are difficult problems. And these problems are due to the nature of the way that data is stored in databases. Databases, the more powerful they are, you don't tend to like just update records. You store a new record every time there's a transaction. And therefore, it makes many of these problems to be time series problems with multiple columns. So that makes them multivariate time series problems. And it makes it so that you have to kind of deal with this. Now, MindsDB can handle this. For the sake of this example, we're going to talk about one specific scenario, which is anomaly detection. Those can be either in time series or not. And I want to introduce you to my colleague, Patricio, who will walk you through one demo end-to-end for anomaly detection. And again, this is just the tip of the iceberg. We just want to give you a teaser. Go into MindsDB and then see the rest there. Patricio?
Thank you, Jorge. Let me just go back one slide. I'll try to paint a picture here regarding the scenario that we'll tackle. And essentially, the dataset that we'll take a look at is a Kaggle dataset. For those of you who don't know, Kaggle is a sort of website for competing in machine learning tasks or challenges. And one of the most used datasets for exploring techniques or just trying your hand at being essentially what a machine learning engineer would do is this credit card fraud detection dataset, right? Which has anonymized transactions from different credit cards all over the world. And you have a specific column that will tell you if the transaction was fraudulent or not fraudulent, so normal, right? Now, the interesting bit here is that not only are the transactions anonymized, the actual features are as well. And by anonymized, I really mean that what happened was an engineer or a group of engineers took a bunch of different properties of the transaction, and then they passed this through a technique called PCA, Principal Component Analysis. And this technique, in short, it really gives you back a set of features that are a combination of the original features that will hope to explain what is the actual source of variation in your problem. So essentially, all the variables we have to tackle and learn from this problem are not really immediately obvious in terms of what they mean. So you don't have such an easy explanation to get to, okay, given a transaction, this is going for sure to be a very important property of it, right? So that's one thing. It's only numerical inputs. Now, the other interesting thing about this problem is that even though you have about 300,000 records, only 500 of them are really anomalies. So this is what we call in machine learning a highly unbalanced dataset, just because the anomalies are so few compared to the normal transactions or the normal data points, right? So long story short, what we are trying to achieve here is to design a machine learning model that will enable us to predict whether a new transaction will be normal or fraudulent. And that means we essentially have to learn to predict for this binary column that will be either fraudulent or normal. Okay, so let's now jump into the demo. For that, I will share my screen. I think you guys are looking at it right now with the infinity right here. So please let me know if you're not seeing dbeaver. This is the software that we're using for the rest of the demo. Now, dbeaver is a database client, and it supports a long list of databases, among them SingleStore. So you can see here, I've got a webinar connection, which is actually a connection to my own SingleStore instance, right? So I've got here the host, the port, a particular database where we'll be working, which is called webinar. And so if I test connection, it will go through, meaning that we're live with my SingleStore cloud cluster. So we'll now take a look at the data. We'll go through some data preprocessing techniques, which is what Jorge was mentioning. It's truly easy to achieve data preprocessing straight from the database. And then we will train a model with a subset of the data using MindsDB. Okay, so first things first, let's just switch to the actual database that we'll use. And let's check the data on its raw full format, right? So this is what we get. You'll see we have a time column, which represents the time from the first transaction that was logged, which is this first row, right? And then in seconds, the amount of seconds that have passed since that first transaction. This is just an integer, and it grows to be pretty big. Now, from the column B1 up until the column B28, we have 28 columns that are yielded by the principal component analysis that was performed here by the original dataset authors. So what this means is that this first column will give you the biggest source of variability in terms of what's important in the original features to explain the behavior, or basically the clustering of what transactions are normal and what transactions are fraudulent. Now, that in and of itself is denoted by this column right here, class, where a class 0 means a normal transaction and class 1 means a fraudulent transaction. The last column here is the amount of the credit card transaction, and it is the only one that's not anonymized, and it may be fairly interesting to check for the anomalies, whether they are by large amounts, small amounts, and so on. So just to confirm, we do have about 300,000 records. And again, just to confirm the balance in the dataset, you can see that if we group by class, we have only 492 anomalies and, well, 280K normal transactions. So it's really, really unbalanced, right? Here's where, as a data scientist, right, you may start wondering what's the best approach. And so one of the first principles is to just start simple, right? And given that this is a webinar, right, it gives us the perfect excuse to start simple. So what we'll do is we will try to make or turn the data set into something that's a bit less unbalanced. And by that, I mean, essentially, we will create an undersampled subset in terms of the normal amount of transactions. Now, the way to do this is we can create a view, right, called anomalies, where we will essentially store all the weird transactions, right? And you can have a look at those if you want. And they're here, right? So you can see they're distributed in terms of time all over the place. You've got, a bunch of amounts, some of them by one, I assume, cent or $1 really. So nothing immediately obvious jumps out. So we will have to train a model here, right? Now, because there's so many normal transactions, we will just create a sample from the normal records, right? And we'll keep it simple. We'll just more or less give 4 transactions per each anomaly, right? So we will just limit it to 2,000. That's done as well. So we now have the possibility to create a subset of the dataset where we essentially perform a union over these 2 views to create a subset, and we will just shuffle it by ordering by a random value, okay? So this is going to essentially be a small data set worth of, didn't find it, about 2.4K records. So let me see if I can find this. Okay, there we go. I guess it didn't execute correctly, but so we have 2460 records. Now, the interesting thing is that we'll just, because it's shuffled, right? We can just take, let's say, the first 2,000 records to generate a training subset, okay? And then the leftover, we can just call it a test subset. So what we're doing with this is through SingleStore, right? Which offers very quick capabilities to process your data and to figure out and filter what are you looking at. We have created a training dataset and a testing dataset that is not as unbalanced as the original data, but it will offer a good starting point for us to, get a glimpse at how a model might perform here, right? So once you have this, you'll wonder, okay, how do I generate a machine learning model with MindsDB? That's a fair question. And the answer is, well, you just connect to MindsDB. You'll see here I have a local host thing going on where I have a special port, which is connecting to my MindsDB process, which is just a Python process that is, a daemon that is ongoing. And I just connect using a MindsDB user, no password, because that's the configuration I have. You can, of course, set a password if you like. And it's just a simple MySQL interface. Like if we connect right now, you'll see it goes through. We're using a ODBC connector, nothing special really. It's all in place. So now we go to the MindsDB land, right? And so this script in MindsDB, in dbeaver, it's using the MindsDB connection, as you can see. So now if, for example, I show you the databases, whoops, wrong syntax. You'll see I have an information schema, of course, then MindsDB proper, then a files data source, which is where you can upload files. And we'll actually use that one just to give you a glimpse. Then there's views. And these 3 that you see here, they're just connections to other databases that I have. So you have, of course, SingleStore. You can have, in this case, a MariaDB instance. This one's local. It's on my machine. You can also have a remote MariaDB instance for example. This is just an Amazon Web Service one. And as Jorge was mentioning, creating a predictor here is quite simple. So let me show you. We have this command right here, which is pretty big, but really all you need is this. So this part right here is a bit more advanced. I'll explain to you in a second what it means, but this is the basic syntax. So in this case, just because of a small technical difficulty between my SingleStore instance and my computer, I have downloaded the subset that we just created, and I've uploaded it as a file to the files data source in MindsDB, which is a perfect opportunity to also showcase that. Like if you have a file, you can easily upload it to MindsDB from the graphical user interface and use it as well. So the syntax is pretty simple. You actually just create a predictor, you give it a name, and then from the data integration, so the data source that you want to retrieve data from, you will specify a SQL query. In this case, it's as simple as just selecting everything from the credit card train subset that we just created, right? And the task is pretty simple. We want to learn to predict the class. And the class, remember, gave us a 0 if it was a normal transaction and 1 if it was an anomaly. So what is this next bit? Well, it turns out that MindsDB has a powerful backend that it's just the default one where actually we have an option to just bring your own model. But by default, we use something that's called the Lightwood engine. And it has a strong focus on what is called declarative machine learning, which is where you state what you want to happen, and then the engine will figure out the how, and it will automatically train the best model for you given the constraints that you pass. So in this case, from SQL, the way that you access that those specifics is through the using keyword. And in this case, we are passing as arguments to the model a series of parameters that you're seeing here. In particular, what we're doing here is essentially we want to specify the usage of a neural network, right? That's the module in the submodels key. And for this neural network, we actually want 10 epochs so that it won't necessarily train for too long. We will double down on that by specifying a maximum of 100 seconds to train it, and then a few other parameters to, well, in this case, to actually fit on the validation, which internally it's called the development dataset, so that you can get that last extra squeeze out of the data and just train using the validation dataset after you have diagnosed how it's performing. But we also want to avoid searching for hyperparameters because it's a demo. We don't want it to like run forever. So that's the way that you pass advanced arguments to a predictor through SQL. You can go very, very deep on this. There's a bunch of documentation that we can point you to at the end. I'll be happy to send that link over. But long story short, if you execute this, with a new name, because this one exists for showing purposes, it will do a bunch of things. So first, it will, of course, parse the query, create a plan for what needs to be done, right? And then it will call the machine learning backend so that it generates a JSON-like file where all the details of the predictor are specified. And then from that, Python code will be built so that even if you want to go into the specifics of what you're actually using, you can see what is the code that's being executed, and you can actually modify it if you will, like if you really want to. And then finally, it will actually call the learn method. Now, the way to check this is if we recall the predictor name, which is cc_fraud2, you can check the status of this one, and you'll see it's already training in the status here, right? The thing is, of course, in this case, it takes, I think, like 5 minutes to train. So I already have a pre-trained version, which is this one. And you'll see the status is complete. It has a 0.89 accuracy metric, which if we describe the model, we'll actually get to see what type of accuracy. And you'll see here, it's actually the balanced accuracy score, which, because we have a very unbalanced data set, right? This is actually it's a good metric. So we have a good predictor here in our hands, right? And there's a couple of other options that you can use to describe your model and understand a bit better what it is without moving away from SQL, which is understanding the features that were used for each column. So if we expand this, you'll see that for basically all columns except for the target one, we are using a numerical encoder. And it is a feature, not the target. And for the target, we're using a binary encoder because we have either 0 or 1, and we want to predict that specific value, right? And then you can also describe the model, which in this case, we only pass the neural network. By default, MindsDB will explore other options, but in this case, it's just the neural network. So it's selected, and this is the performance or the accuracy that it got. Finally, to make use of the predictor, you can actually pass arbitrary data, like synthetic data, let's say, but you can also, and this is what we're actually doing here, you can also join the predictor as if it were data with the actual input data. So that's what we're doing here. So essentially, we're passing the testing split of the data as one table, as table A, right? And then we're passing the predictor as another table, table B, and joining both. And from that join, we're actually selecting two things. We're selecting the class from TA, which is the actual value, so the real value. And then from table B, we'll select the class that is predicted, right? If you execute this, MindsDB will call the predictor with the data that you passed in the query. It will compile the predictions with the true values, and then it will give you the result, which in this case, as you can see, 2 columns, 1 real, 1 predicted. There are some differences, right? So the predictor is not perfect, but overall, it's as you can see here, a bunch of zeros, so it gets the normal predictions right. Yeah, there's a few mistakes, but overall, this is a nice first step, right? What could be the next steps? Well, you can get more data involved, eventually the entire data set, right? You can also take this model and expose it, because it's SQL, right? You can expose it to business intelligence tools, such as, for instance, Tableau. So if your task is not necessarily fraud detection, but rather maybe time series forecasting, you can see the time series and the predictions, right? The forecast in a visual way. And this is pretty powerful because there's really no concept of deployment. Like as soon as the predictor finished training, right, you're accessing it as if it were data, and that is huge in terms of ML ops. So that's, I guess, a very quick overview. I think we're fine on time. Of this sample data set. That is, I think, a great introduction to how you can apply machine learning to your single store data without necessarily, creating a separate silo for bringing out the data, manipulating it, and then moving it back into SingleStore. So I think that is it. Let me disable my screen sharing. And I think that's actually the entire presentation, right? Let me see. Well, we have Q&A now. I'm not sure if maybe Costa or Dave, you guys want to handle the transition here to the Q&A.
Yeah, thanks, Patricio. Let's wait for a couple of minutes for people to actually post questions. And I see we already have one, so we can start with it. So the question is, excellent demo. What machine learning library is used in MindsDB?
Yeah, that's a great question. So should I put? Okay. So as I was explaining just, I guess, 5 minutes ago, we have a default machine learning backend, which is called Lightwood, and it has this emphasis on generating code so that you are absolutely in control of what's actually being executed. And it supports, it's an AutoML framework, so it supports, classification, regression, time series, even data, like complex data types such as text and images. So that is the default option, but we have support. It's kind of in beta, right? But it exists, support for bring your own model, and you can expose it, I think, through MLflow and Reserve, which, again, if you're not a fan of AutoML or you actually really want to own whatever is being executed, that's a great way of including it. So essentially, just you need to implement a simple interface, and then you'll be able to have the model, as the one that I just showed you here. You will be able to have your own model in there and exposed. So long story short, Lightwood is the name of the library. I can post in the chat right now the web page, which is lightwood.io. And yeah, I encourage you to check it out. And if you want to contribute, we're always, open to that and more than happy. So yeah.
Thanks, Patricio. And I think the next question is for Akmal. What instruments SingleStore has for data prep and cleaning versus tools like Pandas, etc.?
Right. Thank you very much. So, for your question there, Konstantin, essentially, SingleStore is a SQL, distributed SQL database system. Most of the cleaning and the prep work you'd have to do outside before you actually load it into the database. So you'd need to use some kind of ETL type scenario. And there are plenty of tools out there available to help you do this. If you would like to know what my personal preference is and what I tend to use for a lot of my demos and the articles that I write and the blog posts that I do, I use Spark because it's a great way to be able to load something into an environment, do some transformation. When the data are in the right format, just load. And SingleStore has a Spark connector as well, which I use very frequently. It's a great way to get the data in. And then I know that the cleaning is done. My data set is in good shape when it's in the SingleStore database system, and therefore it's perfect for running my SQL queries. Having said that, the other thing to remember is that although MindsDB, you saw the demo there that Patricio did, that MindsDB is awesome. The SingleStore has a little bit of machine learning capability as well. So you can do things like vectors and dot product. So it can store things in a hex format, if you like. And so there is a possibility to do some of that within the database system. But again, the preparation of the data, loading it in, you would do outside of the database system. Per se, the database system doesn't provide those capabilities built in. This is typically the domain of an external tool.
Thanks, Akmal. And we have more questions coming. So the next question is to MindsDB. Can MindsDB handle training model over a table more than 100 million records?
So I want to answer this one. The idea is that you're the expert of your data. So that's why you're using SingleStore. And in that data preparation stage, you decide what is a meaningful data size. MindsDB can try to take as much data as possible. In that process of training the model, it will run some statistical analysis on some of the data features that you have to understand what is the meaningful or representative sample size. So even though you may have gigabytes of data, if there's a lot of repetition within the columns and within the rows, it will try to get the amount of data that it needs for the training. Now, know that for training, it's a one-off task, or a task that you can do with a given frequency. MindsDB supports a retrain command, but this task, depending on the volume of your data and what MindsDB determines is a significant sample, then this task can take a long time. So it's more a decision by design of whoever is training the model. MindsDB can give you a few optimizations that you can make also down the road. You can specify, how many epochs you want to train on. So if you have a lot of rows that have a lot of variance, but you also want your model not to take a long time, you can specify this. But long story short, I think that MindsDB can take large amounts of data, but in many use cases, you don't, even though your entire database may be terabytes, gigabytes, you may not need all that data to train the model. And MindsDB tries to be very clever as to pulling a representative sample from that. And the beauty of that is, it's a shame that on the demo and for the next demo, what we can do is we can focus a lot on the data preparation side of how that larger data set was kind of like distilled to a smaller set, which again, we used a SingleStore query to do that for the sake of failover on the live demo. We switched to a file, but I think that the message here is you can do all the data transformation as well as like the distillation of a smaller set on SingleStore, which is the beauty of using a database, that you can leverage on all the capabilities that you have to pull what you think is the most important information, even though your data set can be, or your database can contain terabytes of data. In most cases, you don't need this. You can pass that to MindsDB, and MindsDB is going to try to optimize that. But you can also do a lot of work on the SQL side, which is what the SingleStore database provides for you.
Okay, maybe I could just add something as well there. So 100 million records to build a machine learning model seems like overkill. Probably, I mean, I've read somewhere, and I think this is something that is fairly typical. A good data scientist can probably build a model on their laptop without requiring hundreds of millions of records. You could, sample, create the model, and then of course you build and test, and then it's an iterative process. Okay, and so certainly SingleStore has no problem storing that quantity of data, but I don't think you'd need all of that to build a model. So.
Yeah, I think that the way you put it is exactly right. Like for most cases, and I think that there's always exceptions to that. And again, you can try to feed as much into the model building engine, in this case MindsDB. But again, the intuition that we have here is that the experts on data are the SingleStore users. If you already know how to query the data, how to massage it, how to put it there, you know really what's there. So as going to the same point that Akmal was mentioning, it's an iterative process. So you may even start with as much data as you think you need, and then later you will start to realize that you can optimize the data that you fit in. And this kind of sub chunks of data you can do all through queries that you run straight in SingleStore. That's one thing. And the other thing is that SingleStore itself comes with like very powerful statistical properties of like so you can inspect the statistical distributions of the data you have. All of this you can do straight in SingleStore, so you don't even have to extract for many of these operations the data somewhere else to analyze and make those decisions. I think that one of the beauties of using a tool as powerful as SingleStore is that you can leverage on that experience without having to build it yourself.
Yeah, thanks Jorge and Akmal for extended answer. And we have the next question. Can we deploy MindsDB over a cluster?
Yeah, so MindsDB open source as now. It's something that you can deploy in a container, and then you can kind of distribute those containers as much as you want. A lot of the work that we do in the cloud is breaking down MindsDB into kind of like smaller units of work that can be clustered. And I think that that's the advantage of having it on a managed version of MindsDB, which is that you can scale that much more effectively. You could do this on your own, but then you have to build the infrastructure to maintain and orchestrate the different workloads across like the cluster. But yeah, you can. I mean, again, it can be MindsDB ships in containers as well, so you can kind of like distribute that into as many clusters as you want, and then you can have a load balancer on top of that. But and then they can all point to the same metadata database. So essentially, each instance is working as a cluster node. However, the reason why we provide a MindsDB managed version on the cloud is so that people that have that need, we can offload that from their shoulders.
Thanks, Jorge. I assume if any our event guests have specific requests on that, they may reach out to you. And I guess you have your contact details in this presentation. So please feel free to get in touch with Jorge if you really want to deploy it as a cluster. And we have one more question. I assume it came from like a previous answer. You mentioned model retrain, and can you talk more about it? This is a question for Jorge.
Yeah. So one of the problems with machine learning and applied machine learning is that data is a moving animal, and that is an intuition that changes when you go from just doing machine learning for research and then doing it for applied machine learning. The database is not a constant. It doesn't have a constant state. It mutates as you add and insert and delete and all the operations that you have on your data, and that means that the data that you trained on may drift, or like the distribution of this data may drift over time. And this is natural, and it's a normal thing. It's the way that data works. And given that the data is moving and changing and drifting from or the distribution is drifting over time. What MindsDB decided to do is to give you the capability to, once in whatever frequency you define that your data drifts, then you can retrain the model. Essentially, MindsDB already knows what query to run from, and again, since that query, the results of those query may change over time. When you do the retrain, MindsDB just pulls the latest query of that and then learns from that new distribution. This is very powerful because then you can see a parallel to this is a materialized view. You may have a materialized view, and as your data changes, you may want to refresh that view. So the same thing is true to a model. You may have a model that learned from some data, and then let's assume that every week or every month you think that maybe the model can learn new things. Then you just run the retrain model, and then you can have jobs for this. So you can leverage all the kind of like DevOps infrastructure exists for that, like dbt, etc., for ensuring that you can have this in a repetitive and kind of like in the loop process.
Yeah, thanks, Jorge. Oh, and we have one more question from Masood. Is there a solution for training model for streaming data, or we should run prediction from scratch?
Yeah, that's a great question. So I think that at some point, Akmal and I, we were discussing of how we can leverage on the pipeline capabilities that SingleStore has. And this thing of machine learning in the loop is certainly a trend that we're starting to see. So we do support just the same way as SingleStore supports ingesting from streams or topics in Kafka. MindsDB can plug a model that you train. Say, for instance, you have all your data in SingleStore, but then you want to make real-time predictions. You can pipe the model that you train from SingleStore directly into a Kafka stream or topic, and then out you get the predictions. And there's a lot of work that we want to do with the community on understanding how this can play very well with the way that SingleStore sees pipelines. And I think that is the right intuition. Like data can be seen as there's a state on the data with which you run analysis, or can be seen as a stream, which is more looking at the last n transactions that you haven't observed on a given table. And I think that the approach that SingleStore has taken into this is very clever and smart, and is probably the trend that will follow into seeing data as a stream, or like a dual table or a stream. So right now, the support that we have is, again, piping a model into a Kafka topic, and then you get real-time predictions. But there's a lot of work that we have ahead as well to make sure that it plays as intuitively to those SingleStore users already using pipelines.
Yeah, that's a great question, Masood. Thank you for that. And so if you think about it, so the demo that Patricio did, we're looking at sort of static data there, but if you are a financial organization, you've got customers buying stuff all the time. They're using their credit card, they're doing online, they're using their smartphones. These transactions are coming in real time. And so what you could do is you could combine historical data about the customer's sort of previous purchases, if you like, or credit history or whatever, along with these transactions which are flowing in to give you the full picture, if you like. And that's perfectly possible. So SingleStore can support Kafka streams. We can ingest from a Kafka source, create a topic, very easy to do, and it can do that in parallel as well. Because remember, we're now in a managed service environment. For example, we're running everything in parallel, and so it can potentially ingest huge quantities of data very, very quickly. So that's a great question, I think, and a great scenario to think about as well for future sort of demos as well. I think that would be wonderful.
Yeah, thanks. Thanks a lot for questions and for your answers. And we're just on time, so we have 5 minutes left. And let's wait a couple of minutes more for more questions. Otherwise, I would invite speakers to give their closing remarks. What's next? And we can finish the event.
Yeah, so while we get some more questions, I really want to invite you to join the SingleStore community as well as the MindsDB community if you haven't yet. I think that since you brought up this topic of machine learning in the loop, maybe for those of you that are interested, please contact us via the community, join our Slack, and we can have another session that is more like, okay, how do I take it from, I can train a model, I can do it in an ad hoc manner, but then now let's kind of like put this all together into something that runs on the loop. So seeing data as a stream, leveraging all the capabilities that SingleStore has for this, and be able to then pipe into predictions also as another stream back into SingleStore. So maybe that can be a great follow up into this. And again, it's something that when I met Akmal, we even discussed for a good time. So if you guys are interested into that, please join the community. Send us a message there so that we know who of you are interested in that type of webinar, and we can prepare it for you guys.
Thanks, Jorge, and thanks everyone who attended this event. And I think we have no more questions, so we will be closing the event. And I wish you all the best. And join our Slack community, join our GitHub, and stay in touch. Bye-bye.
Great. Thanks, everyone. Take care.
Thank you.
Thank you. Bye-bye.